So for the first one, I want to solve for x exactly. So if I have, if I have log, let's see here. If I have log of x plus 3 minus log of x minus 1 equals 1. So the first thing I can do is I combine these two logs into a single log. So I get log of x plus 3 over x minus 1 equals 1. And then I can take both sides to the 10th, make both of those exponents of 10. So I could do that. And so I get x plus 3 over x minus 1 equals 10 to the first. And then I can multiply the x plus 1 over. And move everything back to one side, or move all the x's to one side, and the constants over to the other side. So if I subtract an x over here, I get 9x is equal to 3 plus 10, which is 13. So x is equal to 13 divided by 9. So that's the answer here. Okay, and on part B, I get 6 times 1.2 to the x equals 5 times 1.7 to the x. Okay, and so I think the first thing I would do is notice that I have different bases here. So I may have to use you can use a log or a natural log, either way. It doesn't really matter since we have different bases. It doesn't matter what kind of thing we use here. So let's start by dividing the 5 over, and so I'll get 6/5 1.2 to the x equals 1.7 to the x. So that's just one thing I can do to simplify it just a little bit. And now I'm just going to take the natural log of both sides. You could use a log base 10 if you want, but I'm just going to use a natural log. So if I take the natural log of both sides, I get 6/5 times 1.2 to the x equals natural log of 1.7 to the x. Okay, and so what I can see here is I have a product inside of this natural log, so I can break it up. So I get natural log of 6/5 plus natural log of 1.2 to the x equals natural log of 1.7 to the x. And now I can bring those powers down. And so I get natural log of 6/5 plus x natural log of 1.2 equals x natural log of 1.7. And so now my goal is to solve for x. So I'm going to get the things that have x in them on one side and the things that don't have x on the other side. So I get x natural log of 1.2, and I'm going to subtract over the x natural log of 1.7. So minus x natural log of 1.7 equals, and I'll subtract that over, negative natural log of 6/5. Okay, I can pull an x out of here. And I have a subtraction of logs, so I could divide if you want, or you could leave it as natural logs, either way. So if I do natural log of 1.2 minus natural log of 1.7, that's natural log of 1.2 over 1.7. You don't have to combine it if you don't want to, but natural log of 6/5. And then I can divide, since this operation with this x and this natural log is multiplication, I can divide that over on both sides. So x is equal to negative natural log of 6/5 divided by natural log of 1.2 over 1.7. And you can't simplify that anymore, but you can get a decimal approximation for it if you want. So if we type all that into our calculator, negative natural log of 6/5 divided by natural log of 1.2 divided by 1.7, we get 0.523. Did it say how many decimal places to round? 2 decimal places, so 0.52. Okay, so that's that. And how about number 10 then? So for number 10, it says again, solve for x. Give your answer in exact form. Let's take it over here and we'll solve for x. So 3e to the 2x plus 5e to the 2x equals 7. So one thing I might notice is that these two have a common factor. They both have an e to the 2x, so I can pull that out. E to the 2x times 3 plus 5 equals 7. Well, that's just 8. So we have 8e to the 2x equals 7. So I can divide by the 8. And now I can take the natural log of both sides. So if I take the natural log of both sides, I get 2x, because the natural log of e to the something is just that power, and equals natural log of 7/8. And then I can divide by 2. And we can get a decimal approximation for that. 0.5 times natural log of 7/8. I get negative 0.0667, and it wants the answer in exact form. So that's the answer in exact form. Never mind, we won't do the decimal approximation after all. But if we do the decimal approximation, it's negative 0.0667. So just for your information. Okay, so that's the answer in exact form. So we'll circle that. So that's the answer for number 10, part A. And next one, for 10B, we have the log of 4x plus 5 times the log of 3x squared plus 1 equals 0. Now, since I have a log times another log, I can't combine that into a single log, right? But what we do have is, since we have two things multiplied together equal to 0, we know that if we have two things multiplied together equal to 0, that means either one of them has to be 0. So we can break this up into two equations here. We can have log of 4x plus 5 equals 0, or we can have log of 3x squared plus 1 equals 0. Okay, and so now I can take e of both sides for both of these, take those as powers of e. So we get 4x plus 5 equals e to the 0 is 1. I can subtract the 5. 4x equals negative, 1 minus 5 is negative 4. So x equals negative 1 from that one. And then the other one I can plug in, so I can take, same thing, e to the log of that equals e to the 0. And then I get 3x squared plus 1 equals 1. I can subtract 1. 3x squared equals 0. And so divide by 3. And square root x equals 0. So those are the two solutions. Now we may not need to go in and plug them in to make sure this works. But if I plug in negative 1, so you just have to go back once you get solutions to problems like this and make sure that you don't end up with a negative inside of a log. But I think we're good, because if we do negative 1 squared, 3 times negative 1 squared plus 1 equals is still positive. And if I plug in 0 for x, 4 times 0 plus 5 is positive. So both of those answers should work. So we'll circle them. And those are the answers to 10B. Okay, how about 11? It says, if the price of a gallon of milk climbs at a continuous rate of 3% annually, how many years will it take for the price of milk to double? So, we're going to use this model here. P equals P naught, e to the RT. And our rate here is 3%. So what we want, and then we want the price to double. So in other words, we want this value to be twice the initial value. So 2P naught equals P naught E to the, 3% is 0.03 T, and we want to solve that for T. So the first thing I can do is divide both sides by P naught. The P naughts divide out from both sides, so 2 equals e to the 0.03 T. Now I can take the natural log of both sides. Natural log of 2 is equal to 0.03 T, and then I can divide by that. So T equals natural log of 2 divided by 0.03 And I can get a decimal approximation for that. Natural log of 2 divided by 0.03, and I get 23.1 years. 1049, so years. Okay. Next one, plutonium has a half-life of 87.7 years. How long will it take a sample of plutonium to decrease to 20% of its original mass? So again, I'm setting this up. F of t equals AE to the KT. So what I want to do is, I know it's 87.7 years is the half-life. So what I need to do, first of all, is I need to find K, because it's not given. It's just given us the half-life. So I know that my initial value, so I know my half-life is 87.7 years. So in other words, 2 P naught is equal to P naught E to the K times 87.7. And so we can use that to find the K, because I know that the half-life, whoops, so that's 1/2 P, sorry, not 2 P. Shoot, okay. So this is 0.5 P naught. So we're doing half of the P naught. Yeah, okay, good. So that works. So then I could divide the P naught. So 0.5 is equal to E to the K times 87.7. And then I can take the natural log of both sides. And then I can divide by 87.7. So K equals natural log of 0.5 divided by 87.7, which is negative 0.0079, 0079. Okay, and then now I want to see how long will it take. So now I need to find T. So I want to say, I want it to decrease to 20% of its original mass. So it should take, it takes 87 years for it to go down to half of its original mass. So to go down to 20% of its original mass, it would be, more than 87 years, clearly. So we should be finding a T that's greater than 87.7 years. All right, so we need 0.2 P naught equals P naught E to the, and I'm going to use my K now, negative 0.0079 times T, and I want to find the T that goes with that. So that's the second part. So I can divide off the P naught. 0.2 equals E to the negative 0.0079 T. Then I could take the natural log of both sides. And then I can divide by that number to get T by itself. Natural log of 0.2 divided by negative 0.0079. So I can get a decimal approximation for that. And I get 203.72 years. And I expected that, if we run around to a whole number, maybe 204 years. Okay, and so, yeah, we expected it to be a number greater than 87.7, so that is that. Okay, so number 13, suppose the amount of a radioactive substance is given by that function, where f of t is the amount in milligrams and t years. First thing we want to do is convert it to that kind of form. So in other words, what we want to do is we want to set 20 times 0.645 to the t is equal to, now the initial value would be the same, so 20 e to the k t, and what I'm saying is you can really look at it this way, and what we're equating there is 0.645 equals e to the k. And we just need to find that k. So we can take the natural log of both sides, and we get that k. So if I do, so what is that? K is approximately natural log of 0.645 is negative how many places? Round to 4 down. Negative 0.4385. Okay. And so here is our form then. F of t is equal to 20 e to the negative 0.4385 t. Okay, then what is the continuous decay rate and what is the annual decay rate? Okay, so for my continuous decay rate, so the continuous decay rate is just going to be given by this number here. Is 43.85%. And the annual, I'm going to take this is equal to 0.645 is equal to 1 minus the annual rate. So I can say that the rate is equal to 1 minus 0.645, which is 0.355. So that's 35.5%. Okay. The next one, it's wanting me to graph that function and identify any vertical asymptotes. And so what I might notice, whoops, sorry, let me do the eraser. That's what I meant to do. Okay, so for this one, I want to notice what kind of shift I have here. So if I have the x plus 3, that's the graph of natural log of x, and I want to shift 3 units to the left. Okay, so that's what that means. So I know the original graph of natural log of x goes through 0, 1, and has an asymptote here. But I want to shift that 3 units to the left, so if I do that, then this point is shifted 1, 2, 3 units to the left, so it goes through here. And then this asymptote is shifted 3 units to the left, so that asymptote becomes this asymptote, and so it goes like that. And so I can see that that is, so I've shifted everything to the left is what I've done here by 3 units. And so my my vertical asymptote is x equal negative 2. And my domain is going to be all of the x values that are greater than negative 3, so negative 3 to infinity. Or you can write x is greater than negative 3, so either way, I'm going to write the domain. And the range is going to be all real numbers, or you could write it as negative infinity to infinity. So any y value is going to be achieved on this function. Okay, so the next one, I want to match these things. Okay, so let's think about this. So this says the limit as x approaches negative infinity of f of x is 0. So in other words, as I'm traveling this direction, I want the y values to be getting closer to 0. So in this one, it's not even defined for negative x values, so it's definitely not 1. On this one, for graph 2, as x goes to negative infinity, my y values are negative. And for this one, as x goes to negative infinity, my y values are getting closer and closer to 0, so this is the 1. So it's 3 here. Okay. For the next one, it says it wants the limit as x goes to 0 from the left to be infinity. So what that means is I'm going to be approaching 0 from the left-hand side and looking at what the y value does. So for the first graph, it doesn't even have any x values when x is negative, so that one we can rule out immediately. For this one, as x approaches 0 from the left, my function is going up to infinity. So it looks like this is the one I want. For this one, as x approaches 0 from the left, my y value is getting closer to, looks like maybe some positive x value. So it's some finite positive x value, so it's not that one. So the answer here is 2. And on C, it says it wants the limit as x approaches 0 from the right to be negative infinity. So what I'm looking at is as I'm approaching 0 from the right-hand side, what's happening to my y values. So for the first one, as I approach 0 from the right-hand side, my y values are going down to negative infinity, so that's the one I want. For this one, there are not even any x values, there are not even any y values defined. The function is not defined for any positive x values, so there's not even any function over here, so that one's totally out. For this one, as x approaches 0 from the right, this function is going into some finite positive y value, so it's not negative infinity. So the answer to this one is 1.